Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi to my panels, Sir Sayuti and Dr. Muzaffar. My name is Muhammad Hariz Iskandar bin Khairi. Today I would like to present about my BDP1 project, which is design and development of ultra-wide log spiral rectangle for energy harvesting. Okay, we jump to the table of content first. Okay, this presentation starting with introduction, then problem statement, followed by project objectives and scopes, methodology, preliminary result, and finally conclusion. Introduction. Resources are used quicker than they can be recovered. Eventually, the Earth just can't meet our expanding needs. Alternative energy such as wave energy, biomass energy, and RF energy can help decrease our dependence on natural resources. A RF power harvesting or energy harvesting device captures electromagnetic energy and converts it into a functional direct current voltage. RF energy harvesting as low power sources that can power up or charge devices like lamp and AA batteries. Problem statement. Battery usage increase worldwide has causes negative impact on the environment. However, a wideband energy harvester using a log spiral rectangle offers a solution of this problem. The downside of using log spiral rectangle design is that it quickly grows in size even after just a few turns. Objective. The key objective of this project is to design and develop an antenna and ultra-wideband log spiral rectangle of RF energy harvesting within range of 500 MHz to 3 GHz. Next is to optimize by simulating the log spiral rectangle using CST Studio Suite 2020 application. Finally, to construct the ultra-wideband log spiral rectangle for RF energy harvesting hardware on a PCB. Scope of project. So this project focuses on the usage of ultra-wideband log spiral rectangle for harvesting application. This rectangle will able to operate at 500 MHz to 3 GHz. A rectifier will be designed to complete this rectangle. Methodology. For methodology, I have do parametric study to specify the rectangle, like determine the frequency, gain, bandwidth, and the dating pattern. The next one is the dimension of antenna, like width, length, and radius. Software design. CST Microwave Studio 2020 was used to run a series of simulation. CST is a specialist tool for the 3D electromagnetic simulation of high-frequency components. ADS or Advanced Design System will be used for rectifier design. Fabrication. Design of rectangle is finalized and this project are fabricated. Process flowchart. Okay. The process flowchart of diagram for ultra-wide log spiral rectangle with starting with research and background study on the log spiral rectangle for energy harvesting. Next, I will determine the problem statement and move to design simple rectangle to blend in with simulation. After design the rectangle according to suitable parameter, I will simulate the rectangle. If the simulation success, I will fabricate the design antenna. If not, I will go back to design rectangle according to the suitable parameter. Process flowchart of the rectifier circuit. Starting with receive source from rectangle, then transfer it to the impedance matching, followed by lumps element and convert AC to DC. I must make sure the output voltage is around 1 volt. If not, I will convert to AC from AC to DC back. And if the voltage is around 1 volt, I will implement the rectifier circuit on the rectangle. Designing antenna and substrate. To construct an ultra-wideband log spiral antenna, there are various processes that must be followed in the CST Design Suite 2020. The first step, step 1. I have choose the suitable antenna type from the micro step. in my case, I've choose the planar log spiral. Step 2. Fill in the values for the calculated parameters. So these are the values that I've filled in on the parameters. And then step 3. Design another arm for log spiral antenna. So log spiral actually basically is a dipole antenna which has two arms. So firstly I've done the first arm, then the second arm just duplicate it from the first arm. Step 4. Design a substrate for log spiral antenna. So the substrate is needed for the antenna in the CST. So I just pick the square box here and just fill in the parameter on the grid. Step 5. Discrete port from the both antenna of the log spiral arm. So firstly I need to choose first port, which is P1, and then choose the second port, which is P2. Then press the setup solver to simulate and run the design log spiral antenna. Preliminary result. This is our design log spiral antenna for simulation that I have designed. Antenna parameter. So these are the parameters that I have choose for the design log spiral antenna. The parameter shown for a log spiral antenna with frequency range 500 to 3 GHz. When designing antenna, a precise calculation is required because parameter will affect both antenna size and the antenna result. Return loss S11. The return loss S11 is of a decent antenna should be at least 10 dB. The lower the S11, on the other hand, is significantly superior. However, more improvement will be done to stabilize the return loss. Next is VSWR. A good antenna should have VSWR of 1 to 2, so further improvement is needed to optimize the circuit and get best possible result for VSWR. Radiation of antenna. The energy radiated of an antenna is represented by radiation pattern of the antenna. Graphically, radiation can be plotted as a function of angular position and radial distance from the antenna. These are the radiation pattern video that I've recorded earlier to show about the radiation efficiency or the radiation pattern of the log spiral rectangle. So you can see in the middle one shows the red color, which is the strongest radiation pattern or radiation efficiency on the rectangle, while the yellow to the blue one is the weakest one. So you can see around the log spiral antenna, the middle one is more stronger than the outer side of the rectangle. The strongest signal are 3.1 dBi, while the weakest signal are negative 36.9. Voltage doubler rectifier schematic. Okay. In the wireless energy harvesting system, the rectifier circuit is crucial. As a result, it is fundamental to construct a small but efficient rectifier circuit. The circuit power source is formulated using P1 tune because an antenna response cannot be generated on ADS. Time domain signal for rectification. The rectification is shown entirely in the graph. The value doesn't go below 0. If it's below 0, the rectification is not carried out properly because RF signal blends too much with the DC output voltage. Next one is reflection coefficient of the bridge rectifier. The simulated return loss responses of bridge rectifier is shown in the graph. The rectifier clearly resonates at 2 GHz for 50 ohm input source. So next are the Gantt chart. So this is my Gantt chart for BDP1. And these are my Gantt chart for BDP2. Conclusion. Retina designed for RF, harvesting RF energy from surrounding is the focus of this project. Main goals are to design of an ultra-wideband log spiral antenna with a lower cut frequency of 500 MHz to 3 GHz, and followed by its development. The designing and simulation process for preliminary result will be completed with the anticipated outcomes, and the outcome will be further improved for BDP2 next semester. Thank you and Assalamualaikum for listening my presentation.